Okay, so the activity we're working on now is determining the densities of regular solids. Activity 1. So we're going to use the balance to measure the mass of each cylinder in grams. Record the results in the activity 1 data sheet. So I'm going to write it on a piece of paper and then I'm going to transfer it over. Okay, so basically we're going to start with aluminum, which is silver. We want to turn the scale on. And if it's not at 0, you want to make sure and push tar. This is at 0 for us, so we're good there. We're going to place it there. And now that it says hold, so we have 4.38. We're going to record that down. 38. And then we're going to get the second one, which is acrylic, the clear one. We need to tar this. All right, back to 0. And we have 1.95. So these are in grams, don't forget. Okay. And then lastly, polyethylene. And with that, we have 1.60. 0.60. Good. So now that we've done that, so for the mass, we have 4.38. For aluminum, for acrylic, we have 1.95. And then polyethylene is 1.60. And now on for activity or step 2, we're going to use a ruler, measure the height and diameter of each cylinder in centimeters. It says also record these measurements in table 1. So we're going to start with silver. And we're going to measure the height. So you want to make sure that you're using the centimeter side. I'm going to face it toward me so I can see. You want to get down and make sure you're at eye level. Let's actually do it on here to see if we get a more accurate. I have about 1 centimeter. Then we're going to the clear one. I want to make sure and write that down. That one is 1 centimeter as well. And then lastly, the clear one. Also 1 centimeter. Okay, so moving right along to step 3, now we're going to measure the diameter. Okay, so we're going to start with our silver. Make sure you can see me there. And with this measurement, you want to make sure that the line is just your best educated guess. And I'm getting actually about 1.2. But in step 3, it also makes sure that you are rounding your answers. So we're going to go with 1. Round down. We're going to do the same thing with acrylic. Record that down. I'm also getting about 1.2. Again, it's important to go ahead and round down. I'm sorry, I actually just measured the polyethylene. So we'll go ahead and put that down. No, I was right. The acrylic, and then lastly, the polyethylene. Again, about 1.2 on the polyethylene. So we want to write that down. Okay. So now it's saying we're going to find the radius of each cylinder by dividing the diameter of the circle by 2. So let's go ahead and do that with our calculator here. And I just went ahead and put this in decimal form here. So 1 divided by 2, and if you put that in decimal form, 1/2, it's 0.5. So, okay. 0.5 as well. And in step 4, we are to record these dimensions in the table 1. Okay, so in the 5th step, we're going to calculate the volume of each cylinder using the equation. So it's V equal pi, which is 3.14, times the radius times 2 times the height. So when we do that, so we'll have 3.14 times 0.5 times 2 times 1 equals 3.14. That's for silver. Same thing here. If we do 3.14 times 0.5 times 2 times 1, we get 3.14 again. And then, and then lastly, 3.14 times the radius. Now we're doing the polyethylene. The radius is 0.5 times 2 times the height, which is 1. We get, once again, 3.14. So we've recorded those. Now we're going to calculate the density of each cylinder by dividing its measured mass by its calculated volume. So the equation is D equal M divided by V. I'm going to scoot these up so I can see. Okay. So the mass is 4.38 divided by 3.14. So 4.38 divided by 3.14. Again, this is for aluminum. And we get 1.3949. I didn't see any indication to round, so I'm leaving it in the long form. Next, we have acrylic, which is clear, so it's 1.95 divided by 3.14, and we get 0.621019. Same thing with polyethylene. We're going to go 1.60 divided by 3.14, and on this one we get 0.050955. So that completes Activity 1 data.